Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and in this lesson I'm just going to go over some of the things that I asked you to do in the previous exercise. So some of the things I asked you to look up in the 16F88 datasheet were the following. I want you to find out what port pin the external interrupt is on. I want you to find out how to set this to trigger on a rising edge, because that's what we've been doing up to now. We've been using a rising edge, but we've been checking to see if the edge happened ourselves rather than using a hardware interrupt to do it. I want you to find out how to enable this external interrupt so that when the edge actually occurs on that particular pin that you find, that it causes the interrupt to occur. And I want you to find out how to enable all interrupts. Interrupts in general can be enabled and disabled globally so that they can all be switched on and all be switched off at a particular time using the global interrupt. It's often beneficial to be able to do that. So normally you have an individual enable to enable one particular interrupt, and then you have a global enable. Okay, so we're going to look up those four items, and one other thing that I'm going to point out to you when we look it up is the interrupt flag, which I didn't mention here. Okay, so how do we find this in the data sheet? Because remember, there's quite a lot in the data sheet, so you need to be efficient about the way you find things. So we're going to use the find button. So in most situations, that's Control F on your keyboard. It should bring up a finder dialog there. Okay, so the first thing we want to find out is what pin is the external interrupt on. Now you don't want to write in that full sentence, so just we'll just write external interrupt. And we don't always get it on the first go, so we'll see who we get. So we see a mention of external interrupt, but it doesn't tell us much more there. So let's go and see what's next. Okay, now this is looking much more useful to us. So we can see where it's been selected there, external interrupt, and we can see that it's occurred on ORB0. Now, ORB0 we have been using as the least significant bit of port B for the last good number of programs. Now the problem here is that because the external interrupt occurs on ORB0, if we want to use that interrupt if we want to use that pin as an external interrupt, it means that we can't use it for general purpose input-output. Now we have been doing a number of programs where we have been doing that, and so this is one of the first times where you start to see that while the microcontroller has a lot of functionality, it can't always use it all at once. And this is where you have to start to make compromises. So you may have to decide what other pins you're going to use if you want to use an interrupt. And interrupts are very useful to use, so therefore it's worthwhile being able to use it. So that's maybe a decision we're going to have to make in the next few programs. If we're going to use that external interrupt, how are we going to get around that problem of not being able to use that pin as a general purpose input-output. Okay, so what I suggest to you as we're going through this video is to have a pen and paper beside you. So pause now if you haven't got that and go and get one. And I want you to take down some of these details as you go, because we're going to need these when we go to writing an interrupt function later on. Okay, so the first thing we need to note then is that in answer to the question previously is that ORB0 is the pin on which the external interrupt comes in, and that's on page 9 of the PIC 16F88 document. Okay, so the next thing we want to look up is how do we trigger on a rising edge. Okay, so again we'll just use the sort of things, the sort of words that mightn't appear for anything else. So rising edge, and we'll see what we find. Now this is looking very hopeful. So we can see here that it says interrupt on rising edge of ORB0. So clearly that's exactly what we're looking for. Now what we notice here is that the interrupt can actually occur on either the rising edge or the falling edge. You can decide that yourself as to which you want to cause the interrupt. We've been using the rising edge up to now, so there's no reason necessarily that we might want to change to a falling edge, but you may find certain situations in which you prefer to use the falling edge, and if that's the case, then you can set it to 0 in order to do that. So this is in an option register, and what we could do is we could write to the whole 8-bit register as a whole for different things that we want to do, but easier than that is to use just the individual bits of that, because we can write to individual bits. So we see here mention of INT EDG, so that's in it's in bold there. Okay, that's that line there, INT EDG. So make sure you write that down, make sure it's in capitals. And what we need to make note of on that is that in order to set it as rising edge, we must set that to 1. And I don't really need to say set it to 1, because setting means putting it to 1. Otherwise, we would either say reset or clear to say put it to 0. Okay, so set it. So make sure you take note of that. The next thing we need to look at is how do we enable the external interrupt. Okay, so we'll go looking for that. And we didn't find any results for enable external, so let's try just enable on its own. And we've found lots of these. And we'll notice that we haven't even moved off the page before we found one suggestion of an enable, but this doesn't seem to be the correct one because this is to do with port B. So this is one of the problems with using the words that will appear for several different things. Don't just go for the first one it sees. You make sure it's actually relevant to what you're looking up. So this is not that enable there that's been highlighted, has nothing to do with the external interrupt, nor has that line. Now, this page here is looking a little bit more hopeful, because we can see here that this mentions the int_con, which suggests it's something to do with interrupt control, and it does indeed. Interrupt control register is a readable and writable register that contains various enable and flag bits for the TMR0 register overflow, the RB port change, and the external RB0 interrupt. And obviously it's the external RB interrupt that we're interested in. We can see enable is highlighted in loads of places on this page, so this is clearly an important page for us. And we'll just move down here just to check what page that is. And it's page 19. Okay, so turns out this is an important page for what we want to do. So the first thing we want to do is we want to find out what is the enable. How do we enable the external interrupt? So if we look down through the details here, we can see that this one here, bit 4 of this, and again we could use this whole register if we wanted to, but might be easier to just use the individual bit. So INT, and I would assume that that is 0 IE rather than OIE, because if we look at the other O's that are written there, the O is much wider, whereas the 0 tends to be thinner. So I think on looking at that looks like it's INT 0 IE is what that is actually written. So write that down in your pad as well. And the important bit then is, how do we enable it? Well, we enable it by setting the value. So in other words, putting it to 1. Okay, so INT 0 IE, and set that to enable it. Now, the last question that I asked you was, how do we enable all interrupts? In other words, the global enable. Now, it turns out I think I don't have to move very far on this page, because it's also under the enable section, and it's up there at bit 7. It's called GIE for global interrupt enable, and again we set it, in other words, put it to a value of 1 in order to enable that. So again, write that down in your pad, capital GIE for the global enable, because we're going to have to use that later. Now, just before we leave this section, I want to mention something else that, as I said, was not in the questions, but is something that we're going to require. When an interrupt occurs, it will call the interrupt service routine. On this particular chip, there's only one interrupt service routine that we can write. And even though there are several interrupts that could cause the service routine, we then have to try and figure out which interrupt did call it, and therefore how we should respond. That means checking what interrupt flag has been set. Now, if we look down here at bit 1 of this, we see that we have an interrupt flag that's for the external interrupt that's called INT0IF. So it stands for interrupt 0 IF, I assume is for flag or interrupt flag. Okay. Now, there's two pieces of information in this. What's important here is that, unlike the previous situations where we wanted to enable something, or we wanted to set it to run on a rising edge and we set a value to it, in this case what we're going to do is we're going to check the value of this flag. If it happens to be set, that tells us that that particular type of interrupt, the external interrupt, has occurred. But in brackets here it says must be cleared in software. Now what that means is that when the flag is set, and we check for it and we find it. If we find it, well, obviously we have to deal with the situation that has occurred, that has caused the interrupt, but the other thing we need to do is we need to clear that, because it says it must be cleared by software, and we are the ones that write the software, therefore we are the ones that must clear it. So I want you to take note again in your pad of INT0IF, that's the external interrupt flag bit. If it's set, or in other words, if it's a 1, then the external interrupt has occurred. If that's the case, we have to deal with it, and we must clear it as well. So that means we must put it to a value of 0. Okay, so that's all for this video, and in the next one we'll be going through how to use this in a program.